it says, look at the following, then choose the table that has a pattern different than the others, aka the alien. Use graphs to explain why you chose the table you did. And I'm going to change this. We're going to use graphs, if helpful, or reasoning to explain why you chose the table that you did. I think our reasoning might be a little bit more clear than looking at our graphs on this one, but we'll do it both ways. All right, so if I look at the first table, we've got 1, 15, 2, 12, 3, 9, and 4, 6. What I'm going to be doing is just looking at what's happening to those y values. To get from 15 to 12, it's subtracting 3. To get from 12 to 9, you'd have to subtract 3. And to get from 9 to 6, you'd have to subtract 3. Okay, these next ones, if I'm just looking at their patterns again, on this one I'm going to have to 17 to get to 9, I'm going to be subtracting 8. The next one, 9 minus 8, we're going to be again subtracting 8. And then on the next one, 1 minus negative 7, we're going to have to be subtracting 8. All right, the next one, if I go ahead and look at it, we're going to have 16 minus 9, we'll subtract 7. To get from 9 to 4, we'd have to subtract 5. To get from 4 to 1, we'd have to subtract 3. Okay, and then the next one, to get from 10 to 5, we'd have to subtract 5. To get from 5 to 0, we'd have to subtract 5. And to get from 0 to negative 5, we'd have to subtract 5. One thing I would like to point out is, notice all the other x's go 1, 2, 3, 4. These are still in the second one going by an equal amount, so we're okay doing it the way that we're doing it. So if you'll notice in the first one, it's subtracting a constant every time. The second one, we're subtracting a constant every time. And the fourth one, we're subtracting a constant every time. This middle one, this third one right here, though, notice it's not going down by a constant amount. So I'm guessing that that's going to be our alien, but we are going to go ahead and do a graph just to verify it. And this will be a little bit harder to tell because these are kind of big numbers on the graph, and that might make a little bit of a difference. I'm not going to use much of that negative side. Okay, 115, so I'm going to go to the right one, and then up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Well, up over here. Okay, and then we're going to go over 2, up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I'm going to go over 3, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we're going to go over 4, up 6. 1, 2, 3, 4, 5, 6. And so notice, if you can tell, it looks like it is going down by a constant amount, so that's kind of making a line. Right, the next one, there we go. Oh goodness, this one's 0, 17. Whew. So I'm going to go up 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 0, 17. So stay put and go up 17. 2, 9. So go to the right 2 and then up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2, 9. And then 4, 1. Should be right there. And then 6, negative 7. 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay, and once again, it's going to be hard for me to draw this, but it is making a straight line. So once again, we've got that nice straight line. Okay, the third one, when I go ahead and graph it, boom, 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 boom. Okay, I got to get up to 16. So over 1, up 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So to the right 1 over 16. And then 2, 9, to the right 2, and up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 3, 4. 1, 2, 3, 4, and then 4, 1. Okay, it's kind of almost looks like it's linear again, but this one is actually starting to curve a little bit, even though it's really hard to tell. And then the last one, okay, 5, 10, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 5, 10, 6, 5, we've got 7, 0, and we've got 8, negative 5. And so this one, once again, is a straight line. Okay, graphing kind of was hard on that one because they really kind of all look like straight lines unless you had graph paper. But this one, definitely by looking at the pattern, it was not. So I'm going to say this one's the table, and it does say to explain. It says to use graphs to help you, but my explanation is going to be the third graph is the alien because it is not going down by a constant amount like the others. And just one note on explaining, when it says to explain, you're going to pretend like I am standing right in front of you, and what would you say if I was standing right in front of you? So you're going to write it as if it were a conversation with me. Number 6, other patterns. Use the fact that rides at the Coast Guard Festival are $3 each to, first of all, identify the independent and dependent variables. So first of all, what do I totally have control over? I have the total control over how many rides. So I'm just going to put my independent will be the number of rides. Okay, my dependent, what's going to depend on that? It will depend how much I have to pay. So cost I will pay. All right, and then it says to write a rule. I'm going to wait to write a rule. I'm actually going to, well, I'll go ahead and write my rule. Since my rides are $3 each, I am going to write my rule is going to be y equals 3x, because every time it will go up 3 more when we do that, very similarly to when we did the math curse problems. C, complete a table showing the total amount of money you spend for riding 0, 1, 3, 7, and 15 rides. So just some random amounts of rides. 0, 1, 3, 7, 15. Okay, if I go on no rides, it will cost me no money. If I go on run ride, it will be $3. If I go on 3 rides, 3 times 3 would be $9. 7 rides, 7 times 3 would be $21. And 15 times 3 would be $45. Okay, so my domain, we might be thinking that let's just list the x's, but if you think about this, I can the smallest amount of rides I'm going to go on is 0, and then I guess we'd have to think about what do you think is the largest. I'd probably say maybe 15, so we just go 0 through 15, and I'm going to put a dash on this one because we could do 1 ride, 2 rides, 3 rides, all the way up to 15. Okay, and then my range, the smallest that I would pay is 0, and the largest that I would pay would be $45. Okay, 7, analyzing graphs. Jeff walks from his home to school. Halfway to school, he stops at his grandma's for breakfast. When he is finished with breakfast, he finishes his walk to school. Graph time on the horizontal axis and distance on the vertical axis. So we want to be very careful on this one that we calculate distance. So we're going to do time on the horizontal axis, and we're going to put distance on the vertical axis. So, okay, he starts at home and he gets away from his house. So here's his house right here. House. There we go. So he starts walking and then he stops at his grandma's for breakfast. So it doesn't go back down to the bottom because that would mean he's going back home. So it's just going to stay steady for a while because he's not covering any distance because he's eating breakfast at his grandma's house. And then he finishes his walk to school. So now he continues covering more distance. So there are 3 parts of that graph, and it's going to look something like that.